Okay, well, it's a pleasure to be here. Can everyone hear me all right? Okay, great. I am going to talk kind of quickly. I'm from the East Coast, I can't help it. And I'm going to be showing a bunch of images because I think the pictures are the best way to explain some of this. So I might go kind of quickly through that, but I hope it'll be interesting. And in fact, things are changing so fast in this area that I've already changed the title of my talk. I don't know how that happened, but it's the same content. What I want to give a little bit of context about is the overall trends that are going on and give you a sense of where we are in the world. Where I was last in Virginia, they're already seeing this because they have the second highest subsidence rate in the United States after the Louisiana Delta. They've already had houses that have had to be abandoned. And what's happened is the people who owned these vacation homes first had to elevate them at their personal expense, and then couldn't use them because the septic tanks became exposed by erosion. And then they lost the value of the property and the nest egg that it might have represented to be able to sell it at some point in the future or pass it on to their kids. And then when it got to this point and they're in the critical zone, they had to pay to take these structures down. So that's the way this has gone. And it's very, very important to think ahead because doing nothing has very important costs for the private sector as well as the public sector. So you know the king tides around here are being documented. We're seeing what the future is going to look like on those days of the year when we see especially high tides. This one from last year at the Embarcadero, obviously at the edge of what that seawall can hold back. This one from this winter out in Jenner, showing a flooded recreation area just from the king tide. So we know that this is coming. We know that it's already happening, that we're seeing changes in the flooding regimes. And over the last 10 years that I've been working in sea level rise, at first all the reasonable people said that it was going to be somewhere around 8 inches to a foot. That was back in 2006. And then by 2008 they were saying, well, maybe 2 feet, the reasonable people. And then as the time went on, it started to get to the point where now the reasonable people are saying 3 feet by 2100. But the line of what other people think is going to happen, let me pull out my little has always been higher than what the reasonable people have said is the central projection. So having tracked it for only 10 years, I can tell you that the actual data on sea level rise are tending to track higher lines on these projection graphs. So that's important to know, that it's not the crazies who are out there saying it's going to be 3 feet. Now that's the central projection, and in fact other people are saying it's really going to be something more like, this is in meters, but something more like 5 or 6 feet. And that's today's estimate. 5 years from now, it might be higher. And what I wanted to emphasize with this graph is that for every increment of sea level rise on the vertical end of this graph, we see an acceleration because of the pattern of the curve in how many years it takes to get to that point. So 8 inches of sea level rise might take 25 years now. Out in 2080, it's going to take 6 years. So we really need to do things today that are preparing the foundation for that much accelerated rate in the future. We have a hard time organizing ourselves to spend money and make public decisions. We need to make some good ones that are not short-term stopgaps, but are things that really provide a foundation for major, fast changes later. Rotterdam is a city I've worked a lot on understanding what they've been doing. This is their city's water plan 2.0 from 2006. They were already planning the second round of what they're actually going to do, not just studying their vulnerabilities, but coming up with actions, the second phase of that by 2006. So we're a little behind. We need to catch up and start thinking about actions and not just our vulnerabilities. This illustration is from that report, and what I want to emphasize is that flooding comes from rain, local rain. Flooding comes from rivers upstream, rain that falls someplace else and comes down the river. The flooding comes from sea level rise, and the groundwater rises as the sea level rises. So we're really talking about a squeeze from 4 directions. And thinking about just the sea level is a mistake. It's a strategic problem that most of us have. This is a USGS illustration showing today's sea level, a higher sea level, so rise in sea levels, and a rise in the water table, that zone in the soil where the soil is saturated, full of water if you dig down far enough. Like you're on the beach and you dig down, you get to the point where your hole is full of water. That's the water table. And the water table is rising as sea level rises, and that means that septic tanks, sewer pipes, storm sewers will actually begin to be filled with groundwater at some point in many locations. So we have problems that are coming because of a rising water table in addition to a rising ocean. And I think this is really the frontier of where we're headed in looking at the Bay Area, trying to understand how this is going to expand the geographic area that's affected by sea level rise by quite a bit. So that's a very important dynamic to think about. It's also going to remobilize contaminated sediment in some places. So thinking that we've solved the problem with Superfund projects in the 1980s, that's all coming back. The communities that paid that price in the 80s are going to be re-exposed unless we plan ahead for the relationship between sea level rise and the changes in groundwater. So what conditions exist today that could influence adaptation? I'm going to talk mostly about physical characteristics. This, of course, is the Our Coast, Our Future map of only 10 inches of sea level rise showing San Rafael. And this light blue area is all that would be inundated if we don't do anything by the actual seawater. This is not the groundwater, this is the actual seawater at the point where we've got 10 inches of sea level rise. So that's a lot, obviously. If we get, I'm sorry, I put the wrong label on this. This should be about 20 inch, no, I'm sorry, it should be 3 feet, 100 centimeters. This is about 3 feet, a little more than sea level rise, not 10 inches. And you can see we're flooded almost to where we are right now. So this is a very serious problem with just the salt water, never mind the groundwater. That expands the area that will be affected. So physically, we have a problem because we've built cities on flat places right next to the water. Kind of obvious. With that same 3 meters of sea, or 1 meter, 3 feet of sea level rise, this whole North Bay wetland area is flooded. And at first blush, that might seem okay. Those are plants that are used to being in the water. But in fact, as the sea level rises, we're at risk of having our salt marshes collapse, erode away because of increased wave action and the depth of the water, and become mudflats. So all the work we've done to restore a lot of wetlands in the North Bay and the South Bay could be undone, will be undone by sea level rise. We'll end up with a bay edge that's all mud and no marsh. The South Bay has similar problems. This is only 10 inches of sea level. This one actually is only 10 inches, 25 centimeters of sea level rise. And you can see that a lot of the wetlands are flooded here and pretty much all of Foster City. So Marin County and San Mateo County are really on the leading edge of vulnerability. And Highway 101 down here is actually flooded, where it passes through East Palo Alto. And there's Google down here somewhere, right? So we're at risk of losing the functionality of our highway network. You all have experienced that already, and the rest of the Bay Area will also, if we don't think about how to act for the future. The Bay, because it's a kind of long interior space, is not so much affected by the ocean waves, of course, but by the wind-driven waves that occur in the bay itself. So in the wintertime, often storms come from the southeast. Typical prevailing winds might be from the west. And then this is something that's not as well known to most people. My colleague Mark Stacy at University of California has come up with these models that have now been developed in more sophisticated ways even by the U.S. Geological Survey that show the way that tidal dynamics affect the bay. What this is showing is that as the tide comes into the North Bay, it's kind of dampened. The elevation of the water is somewhat reduced because it's spreading out laterally. The wave spreads over a larger area of the tide, if you can think of it by analogy as a wave. In the South Bay, it's narrowing, that shape is narrowing, and so the tide is amplified. So what that means is if Foster City builds a high wall around itself and East Palo Alto and all those other places, they will actually potentially make flooding farther south in the bay worse. And that should be illegal. We all have a lot to deal with here. Making somebody else's problem worse is not a good idea. So I just wanted to point out there are tidal dynamics we have to understand, maybe also in Richardson Bay. I haven't seen that modeling yet. But we have to think about the prevailing winds, that some parts of our shoreline are more exposed to wind and wave energy than others, and that one size will not fit all for adaptation, because the bay is different on its different sides. Some parts are steeper, some parts are flatter, some parts are more exposed to wave energy or to tidal amplification. These show the different kinds of conditions in a high wave energy regime, a moderate wave energy regime, a low energy kind of sand wave energy regime, and then a very low energy regime for wetlands. So we have to understand something about the context for each site, not only what's happening on the land side, but what's happening on the bay side. That changes our options for what we can do. We can't do a wetland in this location. We might not even be able to do one in this location, but we can sure do something in these locations with wetlands and other kinds of materials, sand. And then we have studies that are starting to show us how wide something like a wetland might have to be able to reduce the amount of wave energy coming in that would affect how deep the water is in a flood on the land. So it's not just the flat, mean surface of the sea level, it's actually the wave run-up, how high the waves come into land, that causes more flooding, and then the wave energy itself is erosive, so it causes more damage. So what people are talking about is using wetlands that might be as narrow as something like 200 feet in width to try to bring wave energy down by a lot. So it doesn't have to be, a mile of wetland. It might be less in many places, and it might still be very effective. I'm talking about cost effective here, not just functionally effective. And that's why we're talking about things like this, what people have been calling a horizontal levee approach, because we could build a very high earthen levee and then try to protect this interior area from wave energy out here and from flooding. But if we build this big wedge shape of wetland, we don't have to build as big a levee. So we're talking about how to get more bang for the buck. If you spend your money on a smaller levee with a wetland, you get multiple benefits. You get habitat, you get human recreation, and you get flood protection for cheaper. So that's an important concept, is thinking about the way things can be paired, the way different strategies for adaptation can be combined. And we know we have a very complex food web, we have a very complex system in the Bay Area and its ecology, and much of it depends on wetlands. So if we allow this train wreck of sea level rise and what most people think of as the right adaptation strategy, wall building, if people build walls and the sea level rises, our wetlands will go away. So we have to be very careful about where we build walls, because that will take away this complex dynamic. This is an image by Mario Tema, a professional photographer from New Orleans, showing one of their new flood walls, and the girls looking over the flood walls trying to see where they live. This is the big problem of building flood walls, is that you become unaware of where you live, what dynamics are going on. Never mind the value of being able to see the water that's part of why you chose to live in a coastal area in the first place. So building walls have a lot of consequences. One I want to point out, this is a tide gate structure that's on the Hayward shoreline right now. Most people think, oh, tide gates, not too bad, it's not a wall. All it does is it closes when the high tide comes, and it keeps the highest tide from going into the wetland. You're going to hear a lot about tide gates. You're going to hear a lot about flood walls. But the fact is, when we've looked at places where they've put in tide gates, we've seen the ungated marsh versus the gated marsh have a lot fewer fish. Not only does it reduce the populations of animals upstream, animals that we want to protect, but it also causes typically more sediment to clog the tributaries upstream, and more invasive plants come into the marsh because that sediment usually brings bad water quality with it. We get more phosphorus, we get more metals, and we see a reduction in quality of the sediment, and so you don't see your native wetland plants. So building a tide gate is going to have very serious ecological consequences, even though it's only cutting out the very high water, the highest water of the tide. So I wanted to show you a couple quick pictures quickly of what it is people are doing in other cities, just to give you a sense of what, this is my greatest hits collection. This is, I think, some good ideas that are being done in other places besides walls. Walls are very problematic. Luckily, they're also expensive, so we should be able to use the price tag to have a broader conversation. This is London. Central London is right here. And in East London, they've decided to buy a lot of land along the tributaries, just flat out buy it for public use. And they've built soccer stadiums, not stadiums, soccer fields in these tributary valleys and parks. And this is an underserved part of London. It's East London, tends to be more recent immigrant families. And it serves them as parks, and it's available to store floodwater. And that's something we all have to do, look up in the watershed and ask ourselves where we can store rainfall so that we can keep the rainfall from being part of the coastal flooding problem. So finding open space along tributaries and buying it is going to be an important part of everybody's strategy to keep the flooding from overwhelming us at the coast. Part of it comes from rivers. Sorry, I'm pushing this on. This is a cool project that the Dutch have built as an experiment, and now they're learning from it and going around the world offering us ideas about how it works. And it's called the sand engine. They took 28 million cubic yards of sand. They call it building with nature, which is kind of funny. 28 million cubic yards you don't usually think of as a natural kind of volume of process of sand movement, but they say they're mimicking the glaciers. So, okay, that's a whole different scale of nature. I can see why they would say that. They put it all in this spot so that over time, the wind and waves are moving this sand up and down the beach to widen the beach. And that's basically the Dutch plan, is to widen their sandy shore in the North Sea to protect themselves from storms and from sea level rise. So they're widening the beach. They dredged it from offshore. They take it in strips to be able to have the least impact on the benthic zone. There's research that supports that that is reasonable. It's recolonized quickly. And the Dutch have a lot of sand because they had the glaciers, and the glaciers did a lot of work, so they have a lot of sand. But this is a strategy that takes advantage of natural dynamics, and that's a smart idea. The other thing the Dutch have done is they've built wet ponds to reveal the water table, this is the groundwater, and to have a little room left for storage for stormwater or for unusual king tide kinds of flooding. And then they've built houses on piles. These are not floating houses, but they've built houses on piles in their stormwater infrastructure system. So they make a little money. They recapture some of the cost to the public by actually selling people houses inside the infrastructure system, which people like to live in. So they offer a different kind of choice for how to build new houses. The Japanese have built something called a super dike, which is basically the same dikes that they had on their rivers before and in coastal areas, and they just widened them. So they're the same height, but a lot wider. Still about 30 feet tall, but now something like 1,400 feet wide, 1,200 feet wide. And they extended everybody's property lines up through that new material, so the same people who owned there before owned later and were able to sell units in these higher rise buildings. I know that this is not a Marin solution. I'm tracking that. But I wanted you to see it anyway. You'll see it around the Bay Area, one place or another. And this is what that looks like from an aerial view, the super dike with high rises on top. And that's maybe the right solution for some parts of the South Bay or places in the North Bay even. We'll see what happens with the pattern of density. And roadways. This is a highway in New Jersey serving Ocean City, in New Jersey. And they're elevating it on a higher causeway because it's begun to flood with storms. We will have to think about what we do with our roadways that are currently on land. Will we elevate them as causeways to allow water to go underneath, or will we put them in tunnels, or will we elevate them on earth, which will prevent water from coming in? We have a lot of choices to make, which Caltrans and MTC, the Metropolitan Transportation Commission, are going to be making actively over the next 10 years and for the rest of our lives. The question I'm asking here is, basically, what could we do around San Francisco Bay in a very basic way? I'm not going to talk about this a lot because other speakers will talk more. But from a landscape architecture perspective, the secret of landscape architecture, as described by one of our practitioners, Rich Haig, is to dig a hole and make a mound. And I've just saved you a lot of money in a graduate program by sharing that with you. So you dig a hole on the land side and you make a mound, and it's possible that in some places we may be able to cut those kinds of Dutch wet ponds that we could put housing in and use to manage our runoff from the land, and then put this habitat wedge of the horizontal levee on the ocean side to make sure we don't lose our wetlands as we go forward. and basically think about a terrace on the bay side and some kind of wet ponds on the land side. And I'm just putting this out there. Every simple idea is wrong. So I know that's going to be wrong in particular locations, but there may be a place where that's the appropriate thing to do, and it's very simple. What we're talking about is basically managing the edge of the bay as a series of micro polders where you make a bunch of decisions about how much is going to be beach, how much is going to be wetland, how much is going to be housing, to pay for it. To pay for it, because someone has to pay for it. I think that's almost my last slide. I just wanted to close with the idea of all of us being able to have a choice like this to move to, instead of having to just elevate houses or build walls around our neighborhoods. I think I have one more slide. Whoops. Which is by Nate Kaufman, who's here in the room. And he was looking in a class I taught at how we might be able to use sand barrier islands to allow wetlands to accrete. This is a part of the East Bay. To allow wetlands to develop behind them that then help to protect highways and make habitat. So if you thought big and bold, those kinds of things might be in the picture, but we definitely are going to have to figure out how to use the land side and the bay side together in a pairing that makes all this work. And with that, thank you. I'll hand this over to the next speaker, or introduction for the next speaker.